everyone, welcome to Sangam Tutorials Gubbi online classes for Ncert, Cbse 10th standard for mathematics and science. So in the previous session on riders of right-angled triangles, we had solved very good riders, about 3 riders in the previous session, and we went with the argumental proof for converse of Pythagoras theorem. It was a very good session where you learned a lot of things, you got a lot of knowledge. So here, converse of Pythagoras theorem will not be asked in your examination for the argumental proof, or in the sense the logical proof. Only the statement will be asked for 1 mark, right? So apart from that, in today's session we will be again going with 4 very important riders based on right-angled triangles, where the problems were being asked in the previous examinations of Cbse question papers, right? So they are taken from, the problems are taken from the previous year papers. So among them, the most important, the most knowledgeable problems, most tricky problems, we have selected very scientifically, and we are going to present them in front of you, right? So the first rider is in front of you. A point O in the interior of rectangle ABCD. So why here rectangle is selected usually on the problems of Pythagoras theorem means because in a rectangle all the 4 angles will be equal to 90 degrees. A rhombus will be taken because when the diagonals bisect each other, they bisect each other perpendicularly, therefore a rhombus will be taken. Why a square will be taken on right angle triangles riders? Because all the 4 angles will be equal to 90 degrees. So here we have taken a rectangle where all the 4 angles will be equal to 90 degrees, and when you draw a diagonal to that, then also we are going to get 2 right angles which are left over very free, right? So therefore these are the concept of right angle triangles, that is the concept of Pythagoras theorem is being used in the different types of quadrilaterals. So here this is the knowledge. Only proving how to prove Pythagoras theorem, solving simple conceptual problems on Pythagoras theorem is not enough. You have to apply the knowledge of Pythagoras theorem to different types of quadrilaterals on different criteria, right? So here we have a rectangle in this rider. So a point O in the interior of rectangle ABCD. So imagine a rectangle ABCD. Inside that somewhere, we do not know the position of the point O, where it is, whether it is at the center of the rectangle or at the edge of the rectangle. We do not know where it is. Just it is in the interior of the rectangle, that is the region which is bounded by the 4 sides of the rectangle. So inside that we have the point O. So rectangle ABCD is that point O is joined with the vertices A, B, C and D. So in a rectangle there are 4 vertices. So we'll take it as he has given that it is A, B, C and D. So if this is the thing, prove that OB square plus OD square is equal to OC square plus OA square. It was one of the most important problem. It was asked once in the state syllabus final examinations, and also in Cbse 2006 final examination. This question is being asked in mathematics, right? So we'll go with the diagram. Very important problem. So first we'll draw a rectangle. We'll take a rectangle here. So we know that in a rectangle opposite sides are equal and opposite sides are parallel, and all the 4 angles are equal to 90 degrees. So let us name the rectangle. This is rectangle ABCD. Okay. Now, so ABCD is a rectangle. We have got the point O in the interior of rectangle ABCD. I don't know where to locate, but the only thing data is it is inside the rectangle ABCD. Okay. I will place the point O here. You can place it anywhere you want. You can place it anywhere you want. Usually in this problem we place it here, because when we join OA, OB, OC and OD, the triangles what we get should be legible. So therefore we place the point O inside the rectangle at this point. Okay. So this is point O. So now point O in the interior of rectangle ABCD is joined with the vertices A, B, C and D. So let us join this. So OA is joined, OB is joined, okay, OC is joined, and OD is joined. So all the four vertices are joined to point O. So we have to prove that the square on OB plus the square on OD is equal to sum of the squares on OC and OA. So the square on OB, that is the square on OB, I hope you are imagining this, the square on OB plus square on OD is equal to square on OC plus square on OA. So this is what we have to prove here. So it looks very fuzzy at this point, but the problem is very nice. Just follow. So let us get into the data. So ABCD is a rectangle. ABCD is a rectangle. So O is a point. O is a point in it. Okay. So OA, OB, OC and OD are joined. OA, OB, OC and OD are joined. Okay. So now to prove that, so let us see what is to be proved. So OB square plus OD square is equal to OC square plus OA square. So this is to be proved. So to prove this, the data what they have given is not sufficient. So therefore we will go with more data by construction. Okay, let us get into the construction. The construction part in this rider is very important. So very simple construction. So now draw a line EF. Draw a line EF. Draw a line EF through O. Draw a line EF through O parallel to AB. Draw a line EF through O parallel to AB or parallel to CD. So because AB is already parallel to CD, now we are drawing EF parallel to AB. So therefore, if EF is parallel to AB, already AB is parallel to CD, therefore EF will also be parallel to CD. So it's a very simple logic. So draw line EF through O parallel to AB. Right. So let us get into the proof. Very important. Now EF is parallel to AB, but AB is parallel to DC. Therefore EF is parallel to DC. That's that logic we write here. So EF is parallel to AB. That is according to construction, but AB is already parallel to CD because ABCD is a rectangle. So according to data, AB is parallel to CD. So therefore EF is parallel to CD. Therefore EF is parallel to CD. So now here this line is parallel to this and this line is parallel to this. So according to one of the rider what we have proved in your 9th standard class, if two sides of a type of parallelogram, if two sides of a parallelogram or a quadrilateral are parallel to each other, then it can be called as a rectangle, because already we have here as 90 degrees and 90 degrees here. So you have drawn line EF parallel to AB, so therefore this angle will be 90 degrees and this angle will be 90 degrees. That is, this angle will be 90, this angle also will be 90. As this line is parallel to this line is already 90 degrees here, this angle is already 90 degrees here, so therefore this angle will be 90 degrees and this angle also will be 90 degrees, because these are the two parallel lines, and if you consider this as the transversal, then the corresponding angles or the interior angles on the same side of the transversal are always supplementary. So among them already, if this angle is 90 degrees, then this angle will also be 90 degrees. The same logic applies here. So EF you are drawn parallel to AB. If you consider CB as the transversal here, this angle is already 90. So therefore the sum of the interior angles on the same side of the transversal is supplementary. So therefore as this angle is already 90 degrees, this angle will be compulsory 90 degrees. So in ABEF quadrilateral, this line is parallel to this is parallel to this according to the data, and all the four angles are equal to 90 degrees. So therefore it becomes a rectangle. So here ABFE is a rectangle. Likewise, CDEF is also a rectangle. So therefore, ABFE and CDEF are rectangles. So this is the first part of the proof, which is very important, totally logically based. Right. Now, we will select two triangles. In triangle AOE, this triangle, and triangle COF, this triangle. Because, why we select these two triangles? Because here I want OA square, which is here, and I want OC square, which is in this triangle. Therefore, I select these two triangles. So, in triangle AOE and triangle COF. In triangle AOE and triangle COF. Okay. Right. First, I will take one triangle. Then we will apply for Pythagoras theorem for another triangle. So, in triangle AOE, angle AEO is equal to 90 degrees. Angle AEO is equal to 90 degrees. So, by applying Pythagoras theorem, OA square is equal to AE square plus OE square. I hope you got this. So, in triangle AOE, angle E is equal to 90 degrees. Opposite to 90 degrees is the hypotenuse. So, therefore, OA square is equal to AE square plus OE square. So, OA square is equal to AE square plus OE square. AE square plus OE square. So, okay. Now, so we will select another triangle, that is triangle COF. So, in triangle COF, angle CFO is equal to 90 degrees. Angle CFO is equal to 90 degrees. So, by applying Pythagoras theorem, right, we get opposite to 90 degrees is the hypotenuse OC. Therefore, OC square is equal to CF square plus YF square. So, OC square is equal to CF square plus YF square. Now, we will add these two equations, that is OC square is equal to AE square plus OE square, and OC square is equal to CF square plus OF square. Will add both equations. So, therefore, OA square plus OC square is equal to OA square plus OC square is equal to AE square plus OE square, AE square plus OE square plus this one CF square plus OF square, CF square plus OF square. So, now we will rearrange this. So, OA square plus OC square is equal to okay, we will rearrange this. AE square is here and OE square is here. So, we will take OE square plus OF square. We will write this first, OE square plus OF square plus this one AE square plus CF square. Alright. So, we will take it as equation 1. We will take this as equation 1 right now. Now, we will select two triangles again. That is triangle DOE, this triangle, and triangle BOF, this triangle. We will select these two triangles. So, why we are selecting those two triangles? Because I need OB square, I get it from this triangle. I need OD square, which I get this from this triangle. So, we will select those two triangles. In triangle DOE, we will apply Pythagoras theorem. So, in triangle DOE, angle DEO is equal to 90 degrees. DEO is equal to 90 degrees. So, therefore, by applying Pythagoras theorem, so opposite to 90 degrees is OD square is equal to DE square plus OE square. So, OD square is equal to DE square plus OE square. DE square plus OE square. Okay. So, now in triangle, we will select another triangle here. In triangle BOF, this is 90 degrees. So, opposite to 90 degrees is OB square. OB square is equal to OF square plus BF square. Okay. in triangle BOF, angle OFB is equal to 90 degrees. So therefore opposite to 90 degrees is OB square. So OB square is equal to OF square plus FB square. So we'll add this, add these two, right? OD square plus OB square equations, we'll add these two. So therefore OD square plus OB square is equal to DE square plus OE square plus this one OF square plus this one FB square. So OD square plus OB square is equal to okay, now we'll keep these two as it is, that is OE square plus OF square will keep as it is. We'll take this DE square plus FB square. So now very simple. So OD square plus OB square is equal to, here we can see OE square plus OF square, the same thing repeats here. AE and FB we will have to check it. AE and FB. AE is here and FB is here. So here, as I have mentioned earlier, ABFE is a rectangle. ABFE is a rectangle. So therefore, instead of AE, I can write instead of FB, I can write AE, because here we have got FB here. So instead of FB, I can write AE, because in rectangle ABFE, opposite sides are equal. So instead of FB, I can write AE, and instead of DE, let us see what can be written. So instead of DE, I can write CF, because CDEF, that is CDEF is a rectangle, so therefore opposite sides are equal. So OE square plus OF square plus, instead of DE I can write CF square plus, instead of BF, that is FB square, I can write AE square, that is AE square. Take it as equation 2. So now when you compare both the equations, that is equation 1 and equation 2. So here OE square is there, OF square is there, CF square is there, AE square is there. So these two things are equal to the same thing. So if two things are equal to the same thing according to the axiom, we can say that OA square plus OC square is equal to, that is OD square plus OB square. So from equations 1 and 2, OA square plus OC square is equal to OD square plus OB square. Hence it is true. So this is a very important 3 marks rider which was asked in Cbse 2006 examination and one of the examination of Karnataka state syllabus in the previous years. I hope you will practice this, right? Okay, let us get into the second problem. Very important, taken from the previous textbook of Ncert, which is the old textbook of Ncert. Very important problem. So it's a combination of, I will give a hint how to solve this. It's a combination of similarity of triangles and Pythagoras theorem. So therefore it's from this problem we can check the knowledge of the student in both the areas, that is areas of similar triangles and also the area of, that is right angle triangles, Pythagoras theorem. Okay, let us get into this. Very important. So in triangle PQR, QM perpendicular to PR. Okay, so let us go with the diagram. Diagram is not given to you, right? So this is a right angle triangle. So QM perpendicular to PR, right? So this becomes QM perpendicular to PR. So this is 90 degrees and this is 90 degrees. And PR square minus PQ square is equal to QR square. So as I proved the Pythagoras theorem in the next session, I hope the possibilities of writing Pythagoras theorem in that note, maybe in the form of note I have given you in that session. So according to that, PR square minus PQ square is equal to QR square. So something like this, PR square minus PQ square is equal to QR square is given. So it's Pythagoras theorem, the other format of Pythagoras theorem, that's all. So using this, prove that QM square is equal to PM into MR. QM square, that is the square on QM is equal to PM into MR. That is, if you make PM as the length and MR as the breadth, then the rectangle what you get. So the square on QM is equal to the area of the rectangle, which is obtained by making PM as the length and MR as the breadth. So that is how what we have to prove here. Okay, let us get into data. We have to practice the problems. So in triangle PQR, QM perpendicular to PR, and PR square minus PQ square is equal to QR square. Okay, this is given. So what is to be proved? To prove that QM square is equal to PM into MR. PM into MR. Okay. So let us get into the proof. Right. So now let us do one thing. Let us take this angle as angle 1. Let us take this angle as angle 2. Let us take this angle as angle 3. And let us take this angle as angle 4. Just for our reference. Or without using the names for the angles, you can do it directly. So if you name it like this, it will be just easy for you, right? So now, in triangle PQR we will take. In triangle PQR, it is given that PR square minus PQ square is equal to QR square. So PR square minus PQ square is equal to QR square. So now let us transpose this minus PQ square to RHS. So that looks like PR square is equal to QR square plus PQ square. So we will see this in this right angle triangle. So PR square, the square on PR is equal to sum of the square on PQ plus QR. Okay, then the square which is built on one side of this triangle is equal to sum of the squares on the other two sides. So if a square on one side of a triangle is equal to sum of the squares on the other two sides of the triangle, then those two sides should contain the right angle according to the converse of Pythagoras theorem. So therefore PQ and QR should contain the right angle. So angle PQR will be equal to 90 degrees. So therefore angle PQR is equal to 90 degrees. So you have to state the reason by converse of Pythagoras theorem. Please write the full format of that. So angle PQR is equal to 90 degrees. Now, so here angle PQR is equal to 90 degrees means angle 1 plus angle 2 is equal to 90 degrees. So therefore angle 1 plus angle 2 is equal to 90 degrees. Right? But as QM is perpendicular to PR in triangle QPM, that is QPM triangle, this angle is 90 degrees. So therefore this angle plus this angle should be equal to 90 degrees, because sum of all the angles in a triangle should be equal to 180 degrees. So among the sum of these three angles, already one of the angle is 90 degrees. Then the sum of the remaining two angles should be equal to 90 degrees. So therefore, in triangle PQM, angle 1 plus angle 3 is equal to 90 degrees. Angle 1 plus angle 3 is equal to 90 degrees. So this angle plus this angle is 90 degrees. This angle plus this angle is 90 degrees. So therefore, angle 3 should be equal to angle 2. Because angle 1 plus angle 2 is 90 degrees, angle 1 plus angle 3 is 90 degrees, So this angle when added to this is 90. This angle when added to this angle is 90. So therefore angle 2 should be equal to angle 3. So therefore angle 2 is equal to angle 3, or angle 3 is equal to angle 2, just for reference. So angle 3 is equal to angle 2, it's a result, right? So now similarly here angle 1 plus angle 2 is equal to 90 degrees. So this is not required for doing, it's understood, but for your convenience I am doing it once again. So angle 1 plus angle 2 is equal to 90 degrees, but angle 2 plus angle 4 is equal to 90 degrees, because in triangle QMR already one of the angle is 90 degrees, then the sum of the remaining two angles should be equal to 90 degrees. So therefore angle 2 plus angle 4 is equal to 90 degrees. Angle 2 plus angle 4 is equal to 90 degrees. So this angle when added to this is 90, and this angle when added to this is 90. So therefore angle 1 should be equal to angle 4. So therefore angle 1 is equal to angle 4. So this is one of the result. This is another result. Now let us consider these two triangles. In triangle PMQ and triangle QMR. In triangle PMQ and triangle PMQ and triangle QMR, right? Now, so just now we have proved that angle 3 is equal to angle 2, that is in this triangle this angle and in this triangle this angle are equal, that is angle 3 is equal to angle 2, that is the result. So angle 3 is equal to angle 2, that is proved. And again in this triangle angle 1 and in this triangle angle 4 are equal, that is what we have proved here. So angle 1 is equal to angle 4, just now we have proved this. Okay, so in these two triangles two pairs of corresponding angles have become equal. So therefore in two triangles, if two pairs of corresponding angles are equal, then they are equiangular. If two triangles are equiangular, according to theorem 1, both the triangles should be similar according to AA similarity criterion. So therefore triangle PMQ and triangle QMR are equiangular, right? So therefore triangle PMQ is similar to triangle QMR according to AA criterion. So if two triangles are similar, we know that their corresponding sides should be proportional. So now we will write the proportionality here. This is one of the angle which is equal to this. This is another angle which is equal to this, and this is 90 degrees and 90 degrees. We will write all the three pairs of corresponding sides. Now in the first triangle, opposite to this angle is QM and this angle's corresponding angle is this. So therefore opposite side of angle, this angle is MR. So it becomes QM by MR. I hope you got it, you remember this. So QM by MR is equal to, we'll go with the second side. This was equal to this, we done it. Now we'll go with this. So for this angle, this is the corresponding angle. So therefore the side opposite to this angle is PM and the side opposite to this angle is QM, that is PM by QM. So PM by QM is equal to, now in this triangle this is 90 degrees and in this triangle this is 90 degrees, therefore they are equal. So opposite to this is PQ, opposite to this is QR. This is PQ by QR. So PQ by QR. So reason is corresponding sides are proportional. Corresponding sides are proportional. So select those two ratios where a thing repeats. So here QM by MR, PM by QM, these two repeat, where QM repeats here. So QM into QM is QM square is equal to PM into MR. So this is what we had to prove, I hope. Yes, it's right. So QM square is equal to PM into MR, hence it is proved. So this is a very important rider, because very important. Why we call it as very important? Because we can check your knowledge of similar triangles, and also we can check your knowledge of Pythagoras theorem. So therefore this problem is very important. Okay, we'll get into the third problem. Very important. This problem is taken off from Ncert textbook, from the optional section at the end of the after the exercises of the exercise problems of right angle triangles. We have some optional problems. From there this problem is picked. Okay. So in the figure, ABC is a triangle in which angle ABC is greater than 90 degrees. Okay. ABC is a triangle in which angle ABC is greater than 90 degrees. So an angle which is greater than 90 degrees but less than 180 is called as an obtuse angle triangle. So therefore triangle ABC is an obtuse angle triangle anyway, and AD perpendicular to BC. AD is perpendicular to BC, which is produced. So from towards B it is produced and this height is taken. So for an obtuse angle triangle, always the height remains outside the triangle. In that manner they have taken that. So AD perpendicular to BC produced. Prove that AC square is equal to, that is square on AC will be equal to the square on AB plus square on BC plus twice, that is 2 into BC into BD. BC into BD in the sense making BC as the length and BD as the breadth. They have constructed a rectangle. So the square on AB plus square on BC plus the area of this rectangle, that is to be proved. So it's not just a very simple problem, not very complicated, but you have to listen very carefully. So let us write the data. So in triangle ABC, angle ABC is greater than 90 degrees and AD perpendicular to BC, right? So we have two right angle triangles here. One is triangle ADC, which is right angle here, and triangle ADB, again right angle here. So you have to recognize the right angle triangles here. So along with that, we have to prove that AC square is equal to AB square plus BC square plus 2BC into BD. So this is what is to be proved. So let us get into the proof. It's very simple, right? So now, in order to get AC square in the LHS, you have to select triangle ADC first. So in triangle ADC, angle D is equal to 90 degrees. So opposite to this is AC square. When we apply Pythagoras theorem, AC square is equal to AD square plus DC square. So in triangle ADC, angle ADC is equal to 90 degrees. Angle ADC is equal to 90 degrees. So by applying Pythagoras theorem, AC square is equal to AD square plus DC square. Okay. So AC square is equal to AD square, let it be as it is, plus DC can be written as DB plus BC. So instead of DC, I am going to write DB plus BC. DB plus BC whole square. So this square cannot be individually given to this because it's in the form of A plus B whole square. So AC square is equal to AD square plus, many of the students write it as DB square plus BC square and keep quiet. That's very wrong, because between these two we have plus sign or minus sign, then this square cannot be distributed for both. If it is DB into BC, then the square can be distributed for both. So this is a silly mistake what we have observed. So it is in the form of A plus B whole square. So let us expand that. DB square plus BC square plus 2 into DB into BC. So it is A square plus B square plus 2 into A into B. Okay, so AC square is equal to now we'll do one thing. Let us take it as equation 1 and proceed. So now let us take in triangle ADB. So in triangle ADB, angle ADB is equal to 90 degrees. So in triangle ADB, angle ADB is equal to 90 degrees. So therefore when we apply Pythagoras theorem, AB square is equal to AD square plus BD square. So AB square is equal to AD square plus BD square. AD square plus BD square. Take it as equation 2. So here you can see we have AD square and we have BD square. So instead of these two, we can substitute that by AB square. So substituting equation 2 in equation 1. So we get AC square is equal to, instead of AD square plus BD square, instead of this AD square plus BD square, as this is equal to AB square, instead of this I can write AB square plus this continues plus BC square plus 2 into BD into BC. So I hope this is to be proved. Yes, AC square is equal to AB square plus BC square plus 2BC into BD, AB square plus BC square plus 2BD into BC, right? So hence it is proved. So it's a very simple 2 marks, right? Very simple. Okay, let us get into the fourth problem, where I am going to give you a hint for doing this. It is very similar to the third problem what we have done just now. So it is on the same lines. So in the figure, ABC is a triangle. ABC is a triangle in which angle ABC is less than 90 degrees. You can see it is less than 90 degrees. It's an acute angle, and AD perpendicular to BC. Produced, that is not produced, we will not take it this, we will not take this. Produced is not here. So AD perpendicular to BC. Prove that AC square is equal to AB square plus BC square minus 2BC into BD. In the previous problem it was plus 2BC into BD, and angle ABC was greater than 90 degrees in the previous problem. So what we have to do is select this triangle, that is in triangle ADC. AC square is equal to AD square plus DC square. AC square is equal to AD square plus DC can be written as BC minus BD. That's the thing here. You have to take it as BC minus BD. That is DC square. Instead of DC square, take it as BC minus BD. So then it becomes AC square is equal to AD square plus BC minus BD whole square. BC minus BD whole square. So that becomes AC square is equal to AD square minus, that is AD square plus BC square plus BD square minus 2BC into BD. So take it as equation 1. Come back, select triangle ADB. So in triangle ADB, AB square is equal to AD square plus BD square. So put that in equation 1, take it as equation 2. That is apply Pythagoras theorem to triangle ADB. Put this, that is apply this in equation 1, what you have got. So instead of AD square plus BD square, substitute it by AB square, you will come and reach to this required thing, right? I hope it's very simple, you will do it. Okay, so I'm coming to the end of this session. I hope you enjoyed all the 4 riders, which are very important. First rider is very important. Please practice that very well. So in tomorrow's session, I will be going with application problems on Pythagoras theorem. Very, very important. And we are going to take some stories. We are going to convert that story into a mathematical form, apply Pythagoras theorem, and reach to the required result. So in tomorrow's session, please wait for that. So until then, stay home, stay safe, and keep learning. Thank you.